Everyone, and welcome to today's Explainer. I am seriously excited you're tuning in because today we're going to make your science revision an absolute breeze. If you're prepping for your exams and feeling maybe just a little bit overwhelmed by all the reactions and definitions, don't even worry about it. We are going to lock in exactly what you need to know about physical and chemical changes. So bring your focus, bring that high energy, and let's master this chapter together.
Right, let's start by picturing this. You're standing in your kitchen. You see a banana sitting on the counter and it's completely covered in brown spots. Then, right next to it, you see an ice cube melting into a little puddle of water. Now ask yourself, what is the core fundamental difference between these two everyday events? Well, one is creating something entirely new with a totally different smell and color, while the other is just changing its form. I mean, you can easily just freeze that water right back into ice, right? That simple everyday mystery is exactly what we're going to unpack today.
So here is our game plan for this explainer. We're going to define the main types of changes, look at some of those chemical reactions that always pop up on exams, explore reversible changes, and then wrap the whole thing up with a quick recap and my absolute top exam tips. Let's get right to it.
Starting with Section 1, Types of Changes, Physical versus Chemical. Okay, let's kick things off with a physical change. The absolute crucial point here is that only physical properties change. We're talking about things like shape, size, and state. Think about crushing a piece of chalk into a fine dust, or maybe folding a blank sheet of paper into a paper airplane. The chalk is still chalk. The paper is still paper. No new substance is formed at all. The material stays exactly the same even if it looks entirely different to your eyes.
Now you want to contrast that directly with a chemical change. And listen up, because the absolute most important keyword phrase you literally must remember for your exams is this: new substance is formed. This happens through a chemical reaction. The original stuff you started with actually transforms into something completely different. There is no going back. Let's lock this comparison into your memory right now. Physical change equals no new substance, just a change in appearance. Chemical change equals a completely new substance is formed. Honestly, this clear this versus that comparison is incredibly likely to be a direct exam question for you, so make absolutely sure you have it memorized cold.
Moving right along to Section 2, Chemical Reactions in Action. Let's actually see these definitions play out with some specific examples.
Think about this classic chemistry experiment. If you mix some vinegar and baking soda in a test tube, it immediately starts fizzing up. That fizzing is actually a gas being created, specifically carbon dioxide. Now, if you pass that carbon dioxide gas through freshly prepared lime water, something pretty magical happens. The clear lime water suddenly turns milky or cloudy. Why does it do that? Because a brand new white substance called calcium carbonate has just been formed. Since a completely new substance was created out of nowhere, this is a perfect textbook example of a chemical change.
And that perfectly sets up another massive exam favorite: burning a magnesium ribbon. When you introduce heat to magnesium while it's exposed to oxygen in the air, it reacts violently. It doesn't just quietly melt. Oh no, it gives off this intense, blinding heat and light, and it leaves behind this powdery white ash. That white powder is actually a totally new thing called magnesium oxide. Because a new white powder is created, you guessed it, it is a definitive chemical change.
Now that burning process we just talked about leads us perfectly to this next definition: combustion. It's basically just a chemical reaction where a substance reacts with oxygen and pumps out heat, light, or sometimes both. But hey, things don't just randomly burst into flames sitting on your desk, right? That brings up a super important concept called ignition temperature. This is the absolute minimum temperature a specific substance needs to reach before it actually catches on fire. For instance, paper has a completely different ignition temperature than a heavy log of wood.
So the crucial takeaway here is that for combustion to even happen, you absolutely must have three specific requirements fulfilled. First, you need a combustible substance. That's basically your fuel. Second, you need oxygen from the air. And third, you need enough heat to actually push that fuel to its ignition temperature. If you remove even one single part of that trio, the fire just stops. This is exactly why wrapping a thick fire blanket around someone whose clothes have caught fire puts out the flames so fast. You are completely suffocating the fire by cutting off step 2, the oxygen supply.
All right, now that we've burned some things down, let's jump into Section 3, Reversible and Natural Changes. We're going to talk about whether we can actually undo the changes we see happening around us.
So reversible changes simply mean you can get the original substance back. Think about it. Melt an ice cube, then just stick that puddle of water right back into the freezer. Boom, it's an ice cube again. But what about irreversible changes? Think about cooking. Can you unchop a carrot? Definitely not. Can you unpop a bowl of popcorn? No way. Just keep this super simple rule in your head. If you can easily undo it, it's reversible. If you are totally stuck with the final result, it's irreversible.
Okay, get ready, because here is a highly tricky question that science teachers absolutely love to throw on exams. Can physical and chemical changes occur in the exact same process? Think about that for a second. Let's figure it out simply by looking at a burning candle.
The answer is yes, they absolutely can. The famous scientist Michael Faraday actually made a brilliant observation about this exact thing. When you light a candle, the solid wax heats up, it melts into a liquid, and it flows down the side. That melting is purely a physical change. It's just liquid wax. But that melted wax is also drawn up the wick, turns into a vapor, and literally burns to create the glowing flame. That vapor burning, that is a chemical change. So, a burning candle is actually a fantastic example of both types of changes happening at the exact same time.
Let's step outside the lab for a quick moment and look at how these changes actually happen in nature over thousands of years. The weathering of rocks is a perfect example of this. Giant rocks break apart due to ice expanding or tree roots pushing through them. That's a classic physical change. But at the exact same time, oxygen and water from the environment are reacting with minerals inside the rock, like iron, turning it into a flaky red rust layer. That's a chemical change. Together, this incredibly slow, constant combination of physical and chemical changes is what eventually grinds down mountains to form the soil we walk on every single day.
All right, we made it to section 4. Quick recap and tips. Consider this section your ultimate study cheat sheet. Time for a rapid-fire recap. Let's lock this in so you don't forget it. Physical changes. Remember, no new substance. Chemical changes. A completely new substance is formed. Always remember the standard test for carbon dioxide. It's the gas that turns lime water milky. Don't forget your fire triangle. Combustion strictly demands fuel, oxygen, and heat. And finally, if a test asks you for a real-world example of a process with both physical and chemical changes, you can confidently write down the burning of a candle.
Now lean in, because I'm going to give you some highly specific exam tips. These are the exact things teachers absolutely love to test you on. First, memorize the precise definition of ignition temperature. It's the minimum temperature at which a substance catches fire. Second, learn the exact reactants for that lime water test we talked about. Know for a fact that mixing vinegar and baking soda is what creates the carbon dioxide gas. And third, practice just looking at everyday daily events and classifying them. Be fully ready to explain to your teacher why chopping a piece of wood is physical, but burning that exact same piece of wood is chemical.
And honestly, with that, you are fully equipped. You've got the core concepts, the best examples, and the insider exam tips. Now you are absolutely ready to revise this chapter quickly and with totally new confidence. Thank you so much for joining me in this explainer today. Before you go, I want to leave you with a quick, fun challenge. Just look around your kitchen today. Between the cooking on the stove, the water boiling, and the food in the fridge, how many chemical changes can you actually spot? Keep that curiosity running hot, and hey, happy studying.